1.62, a small body was launched up an inclined plane set at an angle alpha against the horizontal. Find the coefficient of friction if the time of ascent of the body is nu times less than the time of its descent.
Okay, so here's an inclined plane and here's the body. Okay, this angle is given as alpha. Let's write ascent scenarios under that and descent scenarios under that. Okay, so in the ascent there is an initial velocity. Let's say the time of ascent is t. Okay, in the descent, let's say the initial velocity will be 0, so final velocity is 0 here in the time of ascent. In the descent case, should I write UA? Okay. In the descent case, UD, initial velocity is 0 and time of descent, so time of ascent is nu times less, so time of descent is nu TA. Okay, so these are our known facts. Okay, and we have to find the coefficient of friction. So we can say find K, coefficient of friction. So let's draw the free body diagram for the upward journey. Okay, so in the upward journey there is mg in the downward direction. Okay, since the body is moving upward, there is a friction force in this direction. So let's write Fr, and there is a normal force. There is a normal force right here. Okay, and this is the surface of the plane. Okay, now in the descent case, if we draw the free body diagram, so there will still be the mg force downward, the normal force will still be here, but the friction is now in this direction. Why? Because the body is moving down. Okay, and this is the plane. Okay, this is alpha, this is alpha. Okay, so the net acceleration is in this direction. Net acceleration in both cases is in this direction. So let's say this is a ascent and this is a d for acceleration during the descent, right? So what is MAA? It is Fr plus mg sine alpha. Okay, and obviously n is equals to mg cos alpha, so we can also write n equals mg cos alpha. Okay, in this case as well, n equals mg cos alpha, and in this case MAD, the descent, is equals to mg sine alpha minus Fr. Okay, Now Fr is K, the coefficient of friction, which we need to find, times mg cos alpha, which is the normal force, plus mg sin alpha. Okay, so A becomes K cos alpha plus sin alpha g. Okay, in this case MAD, in short MAD, is mg sin alpha minus Kn, so which is Kmg cos alpha. Okay, so AD is sin alpha minus K cos alpha g. Okay, now what's common between these two? The common thing is the distance traveled, which is S. Is the same distance that is being traveled in both the ascent as well as the descent. Okay, so we can write in ascent case S equals to ut minus half AATA square. Okay, we don't know UA yet, but that can be easily found out. We can write V is 0 equals U minus AT TA. From that we get UA equals AATA. Okay, so this is nothing but AATA square minus half AATA square, so half AATA square. Okay, now in the descent, what's the spelling of descent, by the way? DES? DESCENT. Sorry about that. Okay, now in the descent, S equals ut, which is 0, initial velocity here is 0, plus half AT square, so A of descent TD square. Okay, now both these S's are equal, right? So we can equate that. So AATA square should be equals to ADTD square, or we can write TD by TA square is AA by AD. Now TD by TA is what? That is nu square is AA by AD. So we'll have to divide this by this. So that becomes K cos alpha plus sin alpha divided by sin alpha minus K cos alpha. The G gets cancelled out. So if we rearrange, nu square sin alpha minus K cos alpha equals to K cos alpha plus sin alpha. From that, let's bring K terms on one side. So K cos alpha plus K cos alpha plus nu square cos alpha equals to, so nu square sin alpha minus sin alpha. Okay, so from this K becomes nu square minus 1 sin alpha divided by nu square plus 1 cos alpha, or we can write tan alpha. So now we can find out the value if you want. So 2 square minus 1, 2 square plus 1, and tan 15 degree. If I calculate all this becomes 0.16. So that is the coefficient of friction.